is the algebra of matrices: addition, subtraction, scalar multiplication, and multiplication of matrices. So these first ones, addition, subtraction, and scalar multiplication, those are pretty much how you would expect the things to be. Multiplication is a little bit different, but I'll explain later. Okay, so we can add or subtract two matrices only if they have the same dimension. Okay, so the dimension, remember, is, this is written as m by n, so there's two numbers, and m is the number of rows, and n is the number of columns. Okay, we'll get to some examples later. So like let me just do an example here really quickly. So for example, if I have 1, 2, 3, 4, 5, 6, just some arbitrary numbers. This matrix here is 3 by 2 because there's 3 rows and 2 columns, so it's 3 by 2. Okay, so that's what the dimension is. And for adding or subtracting matrices, they have to have the same dimension. Now, that's not the case for multiplication of matrices. That works a little bit different. We'll get to that later. Okay, number 2, we can multiply two matrices. Well, I'll get to that right now, actually. We can multiply two matrices only if the number of columns in the first matrix is the same as the number of rows in the second matrix. Okay, so what that means is that if we have a matrix, so if A is m by n, and B, in order to multiply A times B in this order, then B would have to be n by something. Okay, so if A is n by n and B is n by p, then that's going to work. And you're going to get a matrix that is, that'll be m by p will be the dimensions of the resulting matrix. Okay, so that's kind of how that works. So let's go through a few examples, concrete examples here. So A is 3 by 3, and B is 4 by 3. So in this first one, you'd be multiplying a 3 by 3 matrix with a 4 by 3 on the right. So 3 by 3 by 4 by 3. These are not the same. So this would not work. Okay, B times A, however, and this is the interesting thing, so sometimes you can have the opposite order actually work. So B is 4 by 3 and A is 3 by 3, and these are equal. So this will work. So so you can check that box right there for BA. Now AA, that's a 3 by 3 matrix with the 3 by 3 matrix, and then these are equal, so that will work. Okay, B times B, that's a 4 by 3 matrix with a 4 by 3 matrix. These are not equal. 3 is not equal to 4, so that would not work. Okay, so those two middle answers actually work, and the other ones don't. Okay, let's look at number 3. Which operations can we perform for a matrix A of any dimension, no matter, so can you always do that no matter what? Okay, so this one can work because the requirement for being able to add matrices is they have the same dimension. So if it's the same matrix, then of course it's going to have the same dimension. This one also works. This is a scalar multiplication, and what happens here is you take the 2 and you multiply by everything. So like for example, if you take this matrix here and multiply it by 2, then you're just distributing the 2 to everything in the matrix. So 2 times 1 is 2, 2 times 3 is 6, 2 times -2 is -4, 2 times 5 is 10. Okay, this is scalar multiplication. Okay, let's see, A times A, that one is not going to necessarily work because here we have the same matrix. If the matrix is 4 by 3, you cannot multiply with itself, because then those two middle ones are not equal. Okay, so just only the first two ones work. Okay, let's move on to, let's talk more about multiplying matrices together. Okay, so number 4. So here's how it works. And first of all, we check the dimensions. This is 3 by 3. That's also 3 by 3. Okay, so 3 rows, 3 columns, 3 rows, 3 columns. So that works out okay. Now, if that's so these can be multiplied because that's equal. Check. And that means that the result is going to be these outside ones, 3 by 3. It will be the resulting matrix, which is written right there. Okay, now let me explain how this works. So there's that 13 right there in the first spot. How the heck did we get 13? Because there's nothing else. But let me explain with this next one right here, how that's done. Okay, so here you come to a slot like here. You say, okay, this is in the first row, right? This is the first row. So that means you identify the first row of the first matrix. So the row comes from the first matrix. The column comes from the second matrix right here. So this entry is row 1, column 2. So I go to row 1 in the first matrix, column 2 in the second matrix. And what you do is you multiply the corresponding entries. So this one times this one. Okay, the first entry. The second entry is in this one with the second entry here. And the third entry here, with the third entry there. Like that. And so what is that? -4. So this is 3 times times -4, that's 12. Minus 5 and then minus 4, which is 3. Okay. So that's going to be the answer for that. For that spot, it's going to be a 3. And let's do this one right here. So again, this is the second row. So you identify the second row here. This is the third column. So you identify the third column and multiply things together. So -4 times -1, that's 4. 2 times 3 is 6. 4 and 6 is 10. 4 times -3 is -12. So that's going to be -12 times plus 10 is -2. That's going to be a -2. And then finally here, we have the third row and the second column. So it's the second, we use the second column again for that one. Okay, so the first one's 5 times -4, plus the second one's -1 times 1. And the third one's 0 times 2. So that's -20 minus 1, which is -21. Okay, so that's how you perform matrix multiplication. And that's how all of these other entries were obtained. Okay, so like, for example, this 13 was the first row in the first column. -4 times, or -3 times 4, that's 12, -12. -5 times -5 is 25. So -12 plus 25 is 13. And then the last one is -2 times 0. So it's just going to be 13. That's how all the entries are obtained here. Okay, so let's move along to number 5. Find the values A and B that make the matrices A and B equal. So for two matrices to be equal, they have to be the same dimension, which these are, and all the entries have to match up. So that has to be that. That one has to be that one. Here, this has got to be a 5. So that means that B has to be 5. I'll put a 5 there. And then, right, this matches up with that one, that matches with that one. And here, these have to match up. So that means A has to be -9. Okay, so -9 and 5 would be the answers there. Okay, for number 6, matrix operation, addition. So here's addition, here's multiplication, here's multiplication. So let's do addition first. Oh, here's some scalar multiplication right here. Okay, so what happens to add matrices? Just add the entries. Okay, so this is pretty much what you'd expect. Okay, so -9 plus, so this entry right here, this entry here would be -9 plus 2. Okay, and then this entry here will be 2 minus 9. And this entry will be -9 plus 8, and so on. Okay, so -9 plus 2, that's -7, -7, -1, and -16. So negative, that matrix is so negative. Okay, number 7. For this one, remember, you're going to distribute this 4 into everything. But, so this, distributing the 4 in, you're going to get 28, 20, 0. I'm just multiplying everything by 4. So this is 4. That's going to be 0. 4 times 7 is 28, and 4 times 5 is 20. Plus this other matrix. Now there's a problem right here, and that is that these matrices are different sizes. So that means that this is not possible. So just write, it says write impossible in any entry. Boo, we can't add them together. Okay, number 5. Here's multiplication. Now, again, the first thing we check for is this is 3 rows and 2 columns. This one's also 3 rows and 2 columns, and these are not equal. So this one's also impossible. If you were to try to multiply it together, then here's what would happen. You got to do the first entry, look at the first row in the first column. When you start multiplying these together, so 5 times 4, 4 times 8, and then there's nothing to multiply the 7 by, so that's kind of confusing as to what you do. But the answer is that you just can't do it. Okay, it's not possible to multiply those matrices together. Okay, let's look at the next one, number 9. This is 2 by 2. This is 2 by 3. So these are different size matrices, but these insides are okay. So you can multiply these together, and you'll get a matrix that is 2 by 3. The outside ones. That one, that one. Okay, so let's look at the entries here. Let's go with the first entry, which is the first row, first column. So we concentrate on that and that. -3 times 2 is -6. Let's see, maybe I should write here. -6 plus 4. Let me do this. Let me write more details now, and then we'll shift to less details. That's -2 right there. Okay, let's go for this slot here. So again, that'll be the first row and second column. First row, second column. And that is -3 times 1 is -3. And then -4 times 8 times 2 is -8. So that's -11. Then we'll go this one right here. So that's the same thing, and then that one. And that's going to be -3 times 1 is -3, and then -4 times 4 is -16. So that's -19. Here we have the second row. So that's -4 times 2, that's -8, minus 1, that's -9. Here is the first row, second column, so that's -4 times 1 is -4 plus 2, that's -2. And then for the last one, we have -4 times 1, that's -4, plus 1 times 4, so that's -4 plus 4, that's 0. Okay, so that would be the answer for that one. Great. Now, let's solve some mysteries with this. Okay, so number 10. Solve the matrix equation for the unknown matrix X. If not possible, enter impossible in any cell of the matrix. Okay, so here's the equation that we're after. So what you can do is subtract A to the other side, like that. And here's B, here's A. So let's see, B minus A would be, they're the same size, so that means we can do that. Okay, so B minus A, so it would be this matrix minus that matrix. 9 minus 1 is 8. 7 minus 6 is 1. 6 minus 9 is -3. And 7 minus 3 is 4. So those are going to be the entries right there. And then you can take the scalar over to the other side also. And so that's again distributing this in, multiply everything here by 1/2, so that's 4. This is 1/2. This is -3 halves, and 4 divided by 2 is 2. Okay, so that matrix, that should work for number 10. Number 11. Carry out the indicated algebraic operation. So here we have 3b plus 2c. Okay, so when we multiply, so here's b, here's c. They're the same size, so this is going to work, because multiplying by a scalar doesn't change it. So let's multiply everything here by 3 first. So that would be 0. This is 3 halves. This is 9. Multiplying this by 3, that's -9, 6, and 0. And then now 2 times c. 0, that times 2 is going to be 3. 2 times -2 is -4. And then 2 times -2, that's -4. 2 times 0 is 0, and 2 times 2 is +4. Okay, so adding these together, the first entries is 0 and 0. This is 3 halves plus 3. That's going to be 9 halves. Yeah, that's going to be 9 halves. I should have just left this as 6 halves instead of simplifying it, because now 3 halves and 6 halves is 9 halves. Okay, 9 minus 4 is 5. -9 plus -4 is -13. And 6 plus 0 is 6. 0 plus 4 is 4. Okay, great. That should work. And let's look at number part B. So 2h plus d. Let's see. Here's h, and here's d. Okay, these are different sizes. So I mean, we could figure a 2h out. That would be -2, -4. Multiply everything by here by 2. But these are the same. These are different sizes. So that means we cannot add these together. So just put impossible. If you just write impossible here, then in the first entry, and then leave all the other entries blank, then it works. You should get the right answer. Okay, let's look at number 12. Carry out the indicated algebraic operation. Okay, so AH. There's A and there's H. So probably best thing is to just write those down. So there's A, there's H. Make sure we copied it down right. Okay, now analysis. This is 2 by 2. That's also 2 by 2. So that means that these inside ones are the same, which means we can multiply these together. Okay, so for this first entry, looking at that and that, 9 times -1 plus 8 times 3. That's -9 plus 24, which is 15. Okay, so the first entry is going to be 15. Okay, now this entry, it's also going to be the first row, but the second column this time. 9 times 0 is 0, plus 8 times -2, that's -16. And the this entry here will be this row times this column. So -2 times -1, that's +2. And then 3 times 3 is 9. So 2 plus 9 is 11. And then for this last one, it's the second row and the second column. So second row here, second column there. So -2 times 0, that's 0. And then 3 times -2, that's -6. Okay, so that should be the answer right there, 15, -16, 11, and -6. Okay, here, oh no. The math is laughing at us. This is just great. This is just like really great. Okay, so you put the H first, and then you put the A. Okay, now the interesting thing here is that multiplication of matrices is not what you would call commutative. That means that A times H and H times A could give completely different things. And we have seen previously that sometimes you can multiply A times H, but you can't multiply H times A. You can't reverse. So sometimes you can't even, the one you can actually do the multiplication, the other one you can't even do it. And even when you can do both of them and you're going to get the same size matrix, like this right here, this is 2 by 2, you're going to get a 2 by 2 matrix, okay? But even in that case, you're usually not going to get the same answers. So like if we go for this first slot here, -1 times 9 is -9 plus 0. So that's going to be -9. So notice that those are already different right there. That's a 15, that's a -9. And so those are not going to be equal to each other. Okay, that's the main point of doing that one. Okay, so now this next slot here, that's going to be this one times that. So that's negative 1 times 8, that's negative 8 plus 0, so that's negative 8. And then here, let me put these in other colors. This one times this one, so 27 plus 4, that's 31. And then here, this last one would be this row and this column. So 3 times 8 is 24, and then minus 6, that's 18. Okay, number 13. So GF, that's this one times this one. Okay, here's another interesting concept of what happens. And here's F. This matrix here is called the identity matrix. And this is a 3 by 3 identity matrix. There's other square matrices. Square means it has the same number of columns. There's rows as columns. There's other square matrices that are also corresponding identity matrices. And what makes it special is that when you multiply anything by the identity matrix, any other matrix by the identity matrix, as long as the multiplication can be carried out, because sometimes, you know, if the sizes don't match up correctly, then you just can't multiply, right? So that doesn't make sense. But when you can multiply it, if you have an identity matrix, it's just going to give you the other matrix. So let me show you how that works. So if we do this slot here, that's going to be that and that. And so negative 8. And then the other edges are going to give you zeros because those are zeroed out, right? And if you look at this slot here, that's this one and the second column. But so this times negative 8 times 0 is 0, and then you have negative 1 times 1, that's negative 1. And then the third one, when you go to negative 2, that's also going to be 0. And you kind of see what's going to happen as you continue on. You'll just get the same matrix back again. Okay, so this is really kind of an important concept for matrices. So that's when you do multiplication, it's going to give you that. Okay. So let me just say something right here. This is the 3 by 3 identity matrix. It's usually referred to as I, matrix I. Or if you wanted to say that 3 by 3, then maybe I3 or something like that would work. But just I is fine. Okay, let's go on to part B. So here we have GE. And so G again is right, this matrix here. And then E is this matrix here. Right here. Okay, so now these are very different sizes. This is 3 by 3. This is 1, 2, this is 3 by 1. But because these match up, then you can multiply it together, and the result will be 3 by 1. It'll just be a matrix like that. Okay, so the first entry will be using this first row times the column. So that's negative 8 times 1 plus negative 1 times 2 plus negative 2 times 0. So let's see, negative 8 minus 2 plus 0. So that's negative 10 in the first slot. For the second slot, we'll use these guys. So 5 times 1 is 5. Negative 9 plus 2 is negative 18. Negative 18 plus 5 is negative 13. So that's going to be negative 13. The last one's 0, by the way. And the last one is, let's see, 8. 8 times 1 is 8. 3 times 2 is 6. 8 and 6 is 14. And then the last is 0, so 14. Okay, great. So, oh, there's more fun. Okay, number 14. They want ABE. ABE. So that is going to be, here's A. And then B is right here. Oh. And then E is this one here. Oh, 1, 2, 0. So there's A, there's B, and there's E. Now, let's look at what these are. This is 2 by 2. This one is 2 by 3 because 2 rows and 3 columns. This one is 3 by 1. So you can multiply A times B. You can multiply B times E. B times E. Okay. Now the nice thing about these is that multiplication of matrices is associative. So what that means is that we can multiply A times B, we can multiply those two together and get a result, and then multiply that result by E, and that will be the answer. Or we can multiply B and E together, get a result, and multiply that by A on the right. So they'll be on the right here. And that will be the same answer as what we got if we did it the other way. It will be the same. So you just choose whatever you think is going to be the easiest. And I believe that if we multiply these two together, that's going to be the easiest. So we'll go ahead and do that. Okay. And then which is going to be a 2 by 1 matrix. Okay. Okay. So that is going to give you a matrix right here. Okay. So for the first entry, we're going to use this row here. That's negative 2 times 1, that's negative 2. And then this times this is going to be 3. So negative 2 plus 3 is 1 plus 0. So that's just going to be 1 right there. And then this entry here will be this row times this column. So negative 5 times 1 is negative 5. Negative 5. And then 4 times 2 is 8. And then negative 2 times 0 is 0. So that's going to be 3. There. And then what we can do is we can multiply these two together. And try not to scribble all over the place. Okay, so multiply these two together. This is 2 by 2, this is 2 by 1. So our result will just be 2 by 1 like this. So this row times this row times the column. So 2 times 1 is 2 plus 0 times 2, that's going to be 2. And then 7 times 1 is 7 plus 5 times 3, that's 15. So 7 plus 15 is 22. So in the end, the result is 2, 22 is the answer. Okay, we can do the same thing for AHE. So A is this one right here, 2, 0, 7, 5. H is this one. And E is this one again. Okay, so now there's a problem right here. That's 2 by 2, that's 2 by 2. So you can multiply these two together because those are equal, so that's fine. But this one here is 3 by 1. And here that's a problem because there's 3 rows and there's only 2 columns. So this means this is impossible. Okay, now, so you might be wondering, why do we do multiplication this way? Well, there are a lot of reasons, and it's good for a lot of applications. Like, for example, video graphics on a computer, they use a lot of multiplication of matrices. That's how you move objects around, how you represent objects in the screen. You represent objects in the screen with matrices. You move them around, you do things with them, you distort it, rotate things. It's just matrix multiplication. You multiply by the right matrix and it will make the object do what you want it to do. Okay, that's basically what it is. And so computers, like a graphics card, will specialize, is basically just for multiplying matrices lots and lots of times, like huge amounts of times in a very short amount of time. So that's one reason. There's a lot of other applications to it. It's like this sort of thing with matrices and the way that they're multiplied together is applicable to a lot of situations in science. Okay, but for you guys, the main reason would be, the short answer would be, okay, so something you can actually see is that if you have a system of equations, you can write that as a matrix equation, okay? And you do that by just doing the coefficients here. So if I copy down the coefficients, so just the coefficients of the x1, that's 8, 4, -5, 3 for the first equation, and then put the 0 over here. Put the 0 over here. And then this one would be 1, 0, -1, 0. And then put the 3 over here. And then this one would be 0, 5, 1, -1, and put the 4 there. Okay, so now here we have an equation. Okay, here's an equation. It's got one side, which we'll call the left-hand side, and the right-hand side. Okay, so the right-hand side is a 3 by 1 matrix. The left-hand side is a product of this matrix is got 3 rows and 4 columns. This is 3 by 4. This matrix is 4 by 1. If we multiply those two together, then we're going to get a 3 by 1 matrix, a 3 by 1 matrix. And it's kind of interesting because the entries that we get, so this will be the left-hand side right here. If I multiply this matrix with this matrix, I get, and I go, okay, so I just do it like we've been doing. You take this first row here and multiply the column. So it's going to be 8 times x1 plus 4 times x2. Oops. Minus 5 times x3. Plus 3x4. Okay, I do that with all the other ones. So this right here is actually the left-hand side of this equation. And then when I have it equal to this other matrix over here, 0, 3, 4, then basically I got it. This is going to be equal to that one, and that gives me the first equation. And then when I multiply these together, I just get the second equation. And that's equal to 3. And then when I multiply this bottom row with this, I get the third equation, and which is equal to 4. So basically this right here, the way this is set up, this is equivalent to this system of equations here.